Hi everybody. Although this video is about increment and decrement operator, don't forget that increment and decrement operator comes in the category of unary operators. So we'll first go through a few simple unary operators and then we'll start with increment and decrement operators. This will take hardly a few minutes. Now first of all, what is the definition of unary operators? So a unary operator is the one which acts only on one operand. If you take example of an operator like plus, the plus operator is sometimes called binary operator because it acts on two operands, whereas the unary operator will act on one operand. Now, the simplest unary operator is called unary minus. To understand unary minus, take this example. In this example, this is binary minus, also called arithmetic minus, and this is unary minus. The unary minus acts only on A, one operand, and the binary minus acts on two operands. It acts on X and minus A. So few more examples of unary minus are these. See, here it acts on X, it acts on 2, and here it acts on X plus 2. The unary minus operator negates the value of its operand. So if you talk about this particular expression, over here you cannot say that the unary minus operator works on x and 2 individually. It acts on entire x plus 2, that means only on one operand, and it negates the value of x plus 2. Okay. Now let's go to the next unary operator, which is called sizeof operator. The first mistake which many students do over here is they give a space between the word size and of. Please note there is no space between size and of, and it is a single word in lowercase. Now what the sizeof operator does? So the sizeof operator will give you the size of its operand in bytes. To understand this, let's directly start with an exercise question. So this is the question. Pause the video and read it. Okay. Now this is the first question. It says size of I. Over here, sizeof is the operator and I is the operand. So what sizeof will do is it will give the size of I in bytes. Since I is of data type int, the answer is 2 bytes, that is 2. So the next one is pretty simple, size of f, which will be 4. Now have a look at the third question. Do one thing, pause the video and write the answer on your own. So what is your answer? Is it 6? 6 is wrong answer. The correct answer over here is 4. Now how come 4? So let's understand this. The first thing which you should realize is that sizeof is a unary operator. So it is not acting on I or F differently. It is acting on I plus F. I plus F is a single operand for sizeof. I is of data type int. F is of data type float. So I plus F combined is of data type float. So basically the sizeof over here is acting on float, and that is why the result is 4 bytes. Now I suggest that you copy these examples and then we'll move on to the next one. Before moving on to the next one, there is something important which I want to talk about. Please understand that the precedence of the unary operators is highest. Precedence is the order in which the operators are evaluated, in which the operation is done. To understand precedence, take this example. Although in this particular expression there is no unary operator, but still you will understand the meaning of precedence. Over here, what do you think? Which operation will be done first, plus or multiplication? The answer is multiplication. So B into C will be done first. So I can say that a precedence of multiplication is higher than plus addition. That way, amongst all the operators, the precedence of unary operators is highest. Okay. Moreover, the associativity of most unary operators is right to left. First, we'll talk about this right to left, and then we'll talk about the word most. So have a look at this particular expression. Again, in this expression there is no unary operator, But let's understand the meaning of associativity. In this expression, there are two operators, addition and subtraction, and they have same precedence. But the associativity of addition and subtraction is left to right, which means that out of these two, plus will be done first and minus will be done later. So associativity is the order in which operations are done in the same precedence group. That means if two operators have same precedence, then we use the concept of associativity. So that way the associativity of unary operators is right to left. If we have two unary operators, then they will be evaluated from right to left. Now why did I highlight the word most over here? That you will come to know when we do increment and decrement operator. Alright, let's go to the third unary operator, which is called which is called type operator. I have already uploaded one video on typecasting. If you have seen that video, then you will understand type operator very easily. In fact, you already know type operator if you have seen that video. So this is one example of type operator. What you see in white color over here is the type operator, also called cast operator. So now what exactly is a type operator? Whenever you write anything in whenever you write any data type in parenthesis, then that thing becomes a type operator and it is used to convert the data type of its operand temporarily. So over here, let's assume that f is of data type float. So when you write this expression, int converts f to, when you write this expression, what happens is f gets converted to data type int temporarily. Take one more example. The type operator over here is int and the operand is I plus f. Don't forget that this type operator is a unary operator, which means it will act only on one operand, which is I plus f. So if I is int, f is float, the combined result of this parenthesis will be float, but it will be temporarily converted to int by this type operator. And that way, this is one more example. Don't forget that between the parentheses, you can write any data type and it will become type operator or cast operator. Finally, let's take one more unary operator, that is logical negation operator given by a single exclamation mark. Now what this operator will do is it will reverse the logical value of its operand. What it means is that if the operand is true, this operator will make it false, and if the operand is false, it will make it true. To understand this, there is one example. A is 5 and B is 6 and I write this. Logical negation of A less than B. Because A less than B is in parenthesis, first we'll solve this. So substitute it. 5 is less than 6, true. So the parenthesis becomes 1. 1 is the value of true. So now this becomes logical negation of true, which is equal to false. So we write the expression is false and its value is 0. So these were some simple unary operators. Now we will go to increment and decrement operator, but I suggest that you copy this much. Now let's start with increment and decrement operator. Increment operator is given by plus plus and decrement operator is given by minus minus. Increment and decrement operators are quite difficult to understand. Moreover, they are very important. In many college exams and placement interviews, questions are often asked on increment and decrement operators. Although they are quite confusing, I assure you that you will understand them properly if you watch this video carefully. So let's get started. The first thing which you need to understand is that increment operator increases the value of its operand by 1 and decrement operator decreases the value of its operand by 1. Except this difference, there is no other difference between increment and decrement operator. So throughout the video, whatever I will tell you about increment operator also holds true about decrement operator. Now let's take some examples. Let's say I is equal to 6. We write plus plus I, after which I will take what value? 7. I is equal to 6, I write minus minus I, after which I will be 5. Let's take two more examples. I is equal to 6, but this time I will write I plus plus, after which I will be again 7. I equal to 6, and I'm sure now you must have guessed I minus minus, and again I is equal to 5. Well, these two are examples of prefix notation, and these two are examples of postfix notation. Pre means before, so in prefix notation the operator comes before the operand. Post means after, so in postfix notation the operator comes after the operand. Now look at these four examples and tell me one thing. As per these four examples, what do you think? The result of prefix notation and postfix notation is same or different? Well, the answer is that the result is same. Whether you write plus plus I or I plus plus, you get I equal to 7, and the same holds true for minus minus I and I minus minus. Now there is one very important rule which you should remember here, and I suggest that you also write this rule. So the rule is, if the expression has only one operator and only one operand, then there is no difference in the result of prefix and postfix notation. So if you watch closely, you will realize in all these expressions there is only one operator and only one operand, and that is why the result of prefix and postfix is same. Remember this rule, and I suggest you also write it. Okay, now let's move on. There is one more rule about increment and decrement operator, and that is that these operators can be used only with a single variable. I repeat, plus plus and minus minus can be used only with a single variable. So if we write something like plus plus 2 and minus minus x plus 2, these expressions are invalid. Now why invalid? It is simple to understand. 2 is not a variable but a constant. Similarly, x plus 2 is not a variable but an expression. So you cannot use minus minus with an expression. It has to be used with a single variable. Now let's understand one very important thing about these operators. Even many teachers have one misconception about these operators. When we write plus plus I or I plus plus, what do you think? Is it same as writing I plus 1? The answer is no. When we write plus plus I or I plus plus, it is same as writing I equal to I plus 1. So this is false, this is true. Now many of you may not understand the subtle difference between these two examples. See, what you should understand is, forget all this, let's take simple algebra. In algebra, if you write A is equal to B plus 1, will it increase the value of B by 1? No. If you want to increase the value of B by 1, you will have to write B is equal to B plus 1. So the same thing happens here also. The value of I will increase only when you store the new value in I again. So plus plus I or I plus plus is actually I equal to I plus 1. And the same thing holds true for decrement operator also. Before moving further, I suggest that you copy all this. Now, let's go into more details of increment and decrement operator. I will show you 4 examples over here. A is equal to 5, B is equal to plus plus A, after which, what do you think will be the value of A and B? So A will be 6, B will be 6, and I will call this as example 1. Let's take this example where we write B is equal to A plus plus. So now, what do you think will be the value of A and B? Well, A is again 6 and B is 5, and I'll call this as example 2. Let's take 2 examples about decrement operator. So A is 5, B equal to minus minus A. Come on, take a guess. What is the new value of A and B? So A is 4, B is 4, example 3. And you all must have guessed what the last example is going to be. A is 5, B equal to minus minus A. So now A will be equal to 4, B will be equal to 5, and I'll call this example number 4. Okay, so now have a look at example 1 and 2. You will realize in both the examples the final value of A is same, but the final value of B is different. The same thing happens here also. The final value of A is same, but that of B differs. So now we need to understand why this happens. So you tell me one thing. In all these expressions, 1, 2, 3, 4, in all these expressions, what I mean is in each of these 4 expressions, you see how many operands or how many operators? So take this for example, here you see how many operands and how many operators? So there are 2 operands, B and A, and there are 2 operators. One is increment and one is assignment operator. This is assignment operator. What I mean to say is, in each of these expressions, this one, and the remaining 2, in each of these expressions, you will see more than one operator and more than one operand. Now what happens is, if the expression has more than one operator or more than one operand, then the result of prefix and postfix notation is not same. And that is what happens here also. I suggest that you write this rule. If the expression has more than one operator or more than one operand, the result of prefix and postfix expression is not same. Now we need to understand that how exactly things work over here. But before that, just understand some terminology over here. Now onwards, plus plus A will be called pre-increment, minus minus A will be called pre-decrement, A plus plus will be called post-increment, A minus minus will be called post-decrement. So now let's understand what happens in pre and what happens in post. Now what happens in pre-increment is, this is pre-increment. So what happens in pre-increment is, the value of A is first incremented and then that incremented value is assigned to B. I repeat, the value of A is first incremented and that incremented value is assigned to B. So what will happen is, if A is equal to 5, first A will be incremented by 1. So A will become 6. And then that incremented value of A equal to 6 will be assigned to B. So B also becomes a 6. Whereas in post increment, what happens is, first the value of A is assigned to B and only after that A is incremented by 1. So here what happens is, the old value of A, which is 5, is assigned to B, and after that A is incremented by 1. So although A is again 6, B is now equal to 5. Please observe in both these examples the final value of A is same. A has to increase whether it is pre-increment or post-increment. But the final value of B is different. The value of B depends on the fact that when A is incremented. If A increments first, then B gets new value. If A increments later, then B gets old value. I hope you have understood this. The same concept is applicable for decrement operator also. Okay. So now let's move ahead. Now let's start with exercise number 1. What I suggest is that you pause the video and read this question and also the note given over here. Okay, so you must have realized that you are given two integer variables a and b, where b is initialized to 0, and you will be given expressions like these. Now what you are supposed to do is, you are supposed to find out the final values of a and b after the execution of the expression. Before I start teaching you how it works, let me tell you something very important. See, what happens is, there are different IDEs for doing a C++ program, like Code Blocks, Dev C++, and Turbo C++. Code Blocks and Dev C++ are based on GCC compiler, and they produce different output than Turbo C++ for increment and decrement operator. Turbo C++ has become quite outdated, and these days most of the universities and colleges use code blocks and dev C++. So what I will do is I will teach you the working of these operators according to code blocks and dev, which are based on GCC compiler. In your college or university exam, you should write the note which you saw on the earlier slide. Okay, so now let's start with the expressions. Now, if you pay attention to these expressions, I'm sure you will have no doubt left in its working. Okay, so let's start. Now over here, the first one says A equal to B plus 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 B plus plus. Now remember that the precedence of unary operators is highest, and the plus plus which you see over here, this one and this one, they are unary operators. Okay. Moreover, their associativity is left to right. The associativity of all other unary operators is right to left. However, the associativity of plus plus and minus minus is left to right. So keep that in your mind. So let's start evaluating them from left to right. Now what is this? Pre-increment or post-increment? Post-increment. So it means that first use the value of b over here. So use the old value of b over here, which is 0. And then its value will be incremented in the computer memory. So let's say this is the computer memory. So within the computer memory, the value of b becomes 1. The white rectangle which you see over here represents the computer memory. Okay. Now we go from left to right. So now we reach over here. Now again this is post increment. Tell me what is the value of b right now? The value of b right now is equal to 1. So 1 is used over here, and then in computer memory b is incremented, so it becomes 2. So now after this is done, addition takes place. Addition operator, the plus operator is arithmetic operator. So now 0 plus 1, a will be equal to 1. And what is the final value of b? It is clearly seen over here. The final value of b is 2. Okay. There is one more way of understanding why b is 2. It is very simple. Look at this expression and you will realize b is incremented how many times? 2 times. So its final value has to be 2. Okay, now let's go to the second expression, which is this. A equal to plus plus b plus 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 b. Alright. So once again, over here you will see computer memory. Now we go from left to right, so we come across plus plus b first. Now this is pre-increment, which means that its value will be increased in the memory first. So look, the value will be increased here to 1. Okay, now be careful, don't do one mistake over here. After increasing the value to 1, don't use the value 1 over here. What you should do is now you should go to the next expression, which is this one. Okay. Now, is this pre or post increment? Again pre increment. So increase its value by 1. So in memory, the value of b now becomes equal to 2. Now what you should do, because they were pre increment, this one and this one, you should use the latest value of b over here. So I will use 2 over here and 2 over here. Okay, so don't do the mistake of substituting here 1. Okay, now simple. A is equal to 2 plus 2 4, and after that b is 2. Now let's go to the next exercise question. What I suggest is that you pause the video and solve it yourself. Okay, now let's see. So left to right, so you come to b plus plus first. Now when you come to b plus plus, it is post or pre? Post. So first use and then increment in the memory. Okay. Now come over here. Post or pre? Pre. So before coming here, before reaching here, the value of b was 1. Now the value of b will become 2 and use the value 2 over here. Now don't have a misconception over here. Don't use the value 2 over here. Why? because over here we had b plus plus, which was post increment. So this will remain 0, but this will be 2. So a will be equal to 2 and b will be equal to 2. Okay. Now let's go to number 4, which is this. Okay. So once again, pre or post? Pre. So if it is pre, first increment in the memory. So in the memory it becomes 1. Because it is pre-increment, don't immediately substitute 1 over here. Wait for some time. Now go over here. So this is b plus plus, pre or post? Post. So use the value 1 over here and then increment it in the memory. Now till here, what is the final value of b? It is 2. So use the final value 2 over here. Okay. So pretty simple. If it is pre-increment, you should wait till the end of the expression. That means till here. Okay. So a is equal to 3 and b is equal to 2. I'm pretty sure that you must have understood these 4 problems properly. Now what will happen is we'll do 8 more problems, and in those 8 problems what we will do is we will take 3 expressions on the right side. If you understand such problems properly, then trust me, you will never ever have a doubt in increment and decrement operators. In this expression, we have a equal to plus plus b, plus 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 b, plus 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 b. In my opinion, this is one of the best examples to understand the working of the increment and decrement operator. If you pay good attention to its working, you will definitely have no doubts. Okay, so let's start. Now in this entire statement, there are 3 categories of operators. This is assignment operator, this and this is an arithmetic operator, and the plus plus is the unary operator. So unary operators have highest precedence. So we start with the working of the unary operator. So first of all, what happens when the compiler comes across plus plus b? Also don't forget that the associativity of this increment and decrement operator is left to right. So we evaluate this one the first. Now because it is pre-increment, what will happen is in the memory its value will increase by 1. So b becomes equal to 1. But as you all know that incremented value will not be used over here. Okay. Now compiler goes from left to right, it reaches here. And because it is pre-increment, again it is incremented to 2. Okay. Now what happens is there is a catch over here. If you don't pay good attention, then you may do a mistake over here. What many students would do over here is that from here they will go over here and they will make b equal to 3. But here comes a twist. Now what GCC compiler does is before going to this plus plus b, it will perform the work of addition which will take place because of this plus. So first of all, the addition will take place over here, and in order to and so that the addition takes place over here, first of all substitution should take place. So now what will happen is the latest value of b is 2, so 2 gets substituted here as well as here. Okay. And now 2 plus 2, 4 is the value of this parenthesis. So please keep in mind that this parenthesis is now equal to 4 and that value will not change. After the addition is done, now the compiler goes to this plus plus b. So b was 2, it becomes a 3. That incremented value is used here. So finally, a is equal to 7 and b is equal to 3. Keep in mind, b was incremented a total of 3 times, as a result of which b is equal to 3. Now let's take this example. After this example, you should have no doubts in your mind. So we have plus plus b plus 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 b plus b plus plus. So let's start pre-increment. So first increment in memory and then go over here. Pre-increment, increment in memory. Now the same twist, the same catch. We have an addition operator over here. So first of all, we need to add and only then we can go ahead. So what is the latest value of b? It is 2. So substitute 2 here and here. So now 2 plus 2 becomes 4, and please keep in mind now this bracket will not change. It has become 4. Now the latest value of b is 2, and this is post increment. So 2 is used here, and then b is incremented to 3. So now a is 6 and b is 3. Come on, let's do the next one. What I suggest is you pause this video and solve it on your own. Okay, now let's see what you have done is correct or incorrect. Come on, let's start. Pre-increment, so increment in the memory. Come over here. Post increment, so use it, so use 1 and then increment in the memory, so becomes 2. Addition operator, so first we need to do addition, for which we need to substitute b over here, which will be 2. Okay. Finally, we have b plus plus, which is post increment. So now use 2 over here and then it becomes 3. So again, final value of b is 3. A is 3 plus 2, 5 and b is 3. Let's go to the 8th one. Whenever you want, you can pause the video and solve it on your own first. Okay. So this is pre-increment. Increment first, so becomes 1. Go over here, post increment, use first and then increment it in the memory, it becomes 2. Because of addition, first substitute this 2 over here, so 2 plus 1 becomes 3. Now no changes possible over here. Go over here, pre-increment, so first increment in the memory, it becomes 3 and use 3 over here. So now a is again equal to 6 and b is equal to 3. Now let's go to problem number 9, in which we have all post increments. So if all are post increments, again if you want you can pause the video and solve it on your own. So let's start. Post increment, so first increase in memory, because it is post increment, first use the old value and then increase in memory. Post increment, first use the old value and then increase in memory. Addition, so apply this addition over here. 0 plus 1 becomes equal to 1. Now again go to this b plus plus, post increment, so increase it, again post increment, so use the old value over here, that is 2, and then you increase it by 1, it becomes 3. So a is 3 and b is 3. Keep one thing in mind, whether it is post increment or pre increment, the final value of b has to be 3 because it is incremented thrice. Now let's go to the next one. So here you have post increment, first use then increment. Post increment, first use and then increment. Now do the addition, so you get this. Now b is currently 2 and this is pre-increment, so first increase and then use it in the memory. So a is equal to 4, b is equal to 3. Now a is equal to b plus 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 b plus b plus plus. So here this is post increment, so first use it then increase, so simple. Pre-increment, first increment. Because of the addition operator over here, you need to do the work of addition, so use the incremented value b of b over here. Okay, so currently b is equal to 2. So if b is equal to 2 and if this is post increment, you use the old value, the current value of b over here, that is 2, and then you increase it to 3, so 3. So a is 4 and b is 3. Now let's take one last one in this particular exercise. So come on, you try doing it on your own. Post increment, so first use then increment in memory. Okay, pre-increment, so first increment in memory. Because of the plus over here, you need to substitute the value of b, which is 2. Now b is equal to 2, so first increment and then use it over here. So A is equal to 5, B is equal to 3. So that was exercise for you. If you can understand this, then I'm sure you'll find increment and decrement operator pretty simple. Now let's go to another exercise. I suggest you pause the video and read the question. Okay, so x is equal to 4, y is equal to 9, and we are supposed to determine the final values of x, y, z after the execution of each of these expressions. So the first expression is this one. So here too, you have assignment operator, you have arithmetic operator, and you have decrement and increment operator. Decrement and increment operator belong to the category of unary operators which have highest precedence. So first of all, we'll work on them. Moreover, the associativity of increment decrement operator is left to right. So which means this will be the first operator we'll work on. Let's start. Now this is post decrement, so use the old value and then decrement it by 1. Same logic. Now we go from left to right. This is pre-decrement, so decrement it by 1. Okay, now use the same logic as in the earlier exercise. We have addition plus over here, so we need to do the addition before we go ahead. So now what you do is you first do the addition, for which you need to substitute the value of y over here, so that is 8. So 4 plus 8 is equal to 12. Now this value will not change, okay? Also keep in mind at this stage x is 3, y is 8, and now we move further towards right. Now y is equal to 8 plus y, so this is pre-increment. So now what happens is y gets incremented in the memory. Again, don't forget there is addition to be done here. So now for that, for the addition to be done here, we need to substitute the value of y, which is 9. So this value is already ready, 4 plus 8, which is 12. It is added with 9, so it becomes 21. Okay. So now this bracket, this parenthesis is equal to 21, which is not going to change. Now again, I move further towards right, minus y, okay, y becomes equal to 8, and use that value over here. So finally, z is equal to 29, the addition of all this. What is the value of x? It is 3, and y is equal to 8, this 8. Okay, so now let's do one more. Again, I suggest you pause the video and solve it on your own. Okay, now let's start. Now, same logic, unary operators have highest precedence, associativity left to right. So this is the first operator we'll work on. It is pre-increment, so increment in memory, but don't use right now. This is post-decrement, so use the value 5 and then decrement it to 4. Because of plus, 4 will be used over here and addition will be done. Okay, moving further to right, plus y, so y is currently equal to 9. In the computer memory, it becomes equal to 10. After it becomes 10, again there is this addition operator over here, so we need to use 10 over here so that addition takes place. So this 4 plus 5 is 9. And plus 10, so the entire parenthesis becomes 19. It becomes 19. Okay, let's move further. Currently y is 10. Y minus minus, so use the old value of y here, which is 10, and then decrement it by 1. It becomes 9. Again, because of this plus, we need to do addition. Okay, so this was 4 plus 5, 9, plus 10, 19, plus 10, 29. Moving further to right, y is currently 9, y plus plus, so post increment, use 9 here and then increment it by 1, it becomes 10. Okay, so finally z is equal to 38, x is equal to 4 and y is equal to 10. Okay, finally let's do one last exercise question on this particular topic. Well, this exercise question comes in many college and university exams, so pay good attention to this. It is quite interesting also. So pause the video and read the question quickly. Okay, so x is 10 and then we have these statements. Let's start with the solution. So z is equal to y is equal to x. So all of them will be given the value 10. Because of this statement, all of them are given the value 10. Now let's start with the first one. Over here, I need to tell you one thing, that all these statements are part of one problem. Okay, so this statement, this statement, this statement, they are not three different problems. They are part of the same problem. Okay, so the first statement is y minus equal to minus minus x. Now keep in mind that is minus equal to is the shorthand assignment operator. In other words, it is the assignment operator whose precedence is least. And this is the decrement operator, pre-decrement operator with highest precedence. So obviously what will happen is first minus minus x will take place. So same old logic. First, the value of x will be decremented in computer memory. So in computer memory, x will become equal to 9. Now the question is, in computer memory, it is 9. Should we take 9 over here? Let's understand that. Now over here, I have minus equal to. So minus equal to is basically y equal to y minus something. It is basically y equal to y minus something. Also keep in mind that apart from this decrement, there is no other decrement or increment which is to be done in this particular statement. So now what will happen is the decremented value of the decremented value of x, which is 9, will be used here, and I have this. So if I expand this, it becomes y equal to y minus 9. So y equal to 10 minus 9. So y becomes equal to 1. And tell me one thing, what is the value of x at this stage? So don't forget, it is 9. Now keep in mind that I told you that this statement is a part of the same problem. So when we take the value of x over here, we'll not start with x equal to 10, we'll start with x equal to 9. Keep that in your mind, okay? Alright, so now let's take the next statement, z minus equal to x minus minus, okay? If you had any doubts over here, your doubt will go away over here, so please be attentive. Now again the same thing. This is assignment operator, this is decrement operator, its precedence is more than assignment operator, so we'll take this first. As you see, it is post decrement, which means I will use the old value over here and then I will decrement it in the memory. Moreover, in this statement there is no other decrement increment operator, so I will use the value of x right away over here. After this, I will expand. So this will become z equal to z minus 9. So z equal to 10 minus 9. So z is 1. And can you tell me what is the value of x over here? Is it 9? No. X will be equal to 8 because of the post decrement which we did here. Okay. This word is off. By mistake, I wrote it or, but you should copy it as off because of post decrement. Anyway, now let's move ahead. But before we move ahead, what is the final value of x till now? It is 8. Now let's take the most interesting and the most confusing one, that is this. Okay, pay good attention. Here you have three categories of operators. This is assignment operator. This and this are decrement operators, that is the category of unary operators. And this is arithmetic operators. So the unary operators have highest precedence. So we'll take this and this first. Let's start. Now this is pre-decrement, which means decrement it in the memory. Okay, and then move ahead. So what will happen is this 8 will become 7. In the computer memory, x will become equal to 7. And then we move over here. Now when you move over here, this is post-decrement. So post-decrement means first use then decrement. So what will happen is that over here x will become 7. Okay, I mean the value 7 will be used for x, and then it will be decremented in the computer memory. So now the question is, over here, I will use the value 7. What value should I use over here? So please pay good attention. Now this is post decrement, so I have used 7 over here, and after that x becomes equal to 6 because of the post decrement. Now remember, from your previous exercises what you have learned is that whenever pre-decrement comes, you should use the latest value for the variable. So the latest value of variable x is not 7 but 6. So this is the next step, very important, and that's why I have highlighted it. Okay, so now this is assignment operator, this is arithmetic operator. The precedence of minus is more than shorthand assignment minus equal to. So first we'll do this minus. So x minus equal to, sorry, I forgot to remind you this, but at this stage x is equal to 6 because of post decrement. You already know that. Okay, so what I was saying is, this is arithmetic minus, this is shorthand assignment operator. The precedence of this is lower than this, so first we'll do this minus. So this is the next step, x minus equal to minus 1. Now do expansion, so you get this. So x is equal to x minus 1, so x is equal to 6 minus minus 1. Don't forget this is minus 1, and this minus comes because of the shorthand assignment operator. So it is basically x equal to x minus 1. So this x is 6. So x is equal to 6 plus 1. So x becomes 7. So finally we get x equal to 7, y equal to 1, and z equal to 1. So guys, this was increment and decrement operator for you. I'm sure this entire video was helpful to you. Thanks and good luck.